Question number 22. It's a nice thing, a little bit of dynamics, a little bit of work energy power. It is something like this. It says there is a block which is released from this inclined plane, and this inclined plane is partially smooth and partially rough. So let's try to see. The CA is rough and BC is smooth, which is mu equals to 0. And it is also found that BC is equal to 2AC. So if I call this as L, the length of AC, BC is going to be 2L. And the question says the block released from rest eventually reaches the bottom, but there the velocity is again 0. Obviously, friction does the negative work. And let's see now, from this we need to calculate the value of mu, and we need to compare with K tan theta. Let me use the mechanical energy equation. Work done by friction is going to be the change in kinetic energy plus change in potential energy. Now the friction does work only for this segment, and that's going to be minus of mu mg cos theta multiplied by length. Change in kinetic energy is 0. And the change in potential energy is going to be minus 3 mgl sine theta. Remember, the height difference would be 3l sine theta. So straightforward, you can see mu equals to 3 tan theta. So the value of K would be 3. Question number 22 will have the correct integer as 3. Let's go for the next, question number 23. Question number 23 is from photoelectric effect, and let's see, it's also a very straightforward one. When the radiation has wavelength lambda, the stopping potential is V, and now the surface is same, and the wavelength is 3 lambda while the stopping potential is V by 4. And in this we need to calculate the threshold wavelength. That means first let's focus our attention to calculate the work function. Now starting with this, E times V, which is the stopping potential, the V, that's going to be equals to hc by lambda minus of hc by lambda naught. The Einstein's photoelectric equation, right? And then the second case, let's say, when the wavelength is 3 lambda, the stopping potential is V by 4. So this is going to be equals to hc by 3 lambda minus of hc by lambda naught. Now this is going to be a straightforward one. When you calculate the value of lambda naught, the value of lambda naught comes out to be 9 times lambda. So therefore the value of n will be 9. So question number 23, that will have the correct integer as 9.